Okay, so now our task is share screen. So now our task is involving the third problem, and the third problem here is our TSP temp. So TSP temp. What is TSP? TSP is a traveling sales person problem, and traveling salesperson is a really important thing for us to understand in what sequence should events be implemented in order to optimize some value. So in this particular problem, let's think about the courier company, and the courier need to go through several cities. For this particular route, the courier has to visit 11 cities, starting from, let's say, Boston, and then it might go to, let's say, New York, because the New York is the closest one. And from New York, it might go to Chicago or to Pittsburgh, and so on and so forth. And um, this problem should be solved like finding the sequence which drives the minimum distance in the end. If we try to solve this problem by ourselves, we find out that the possible combinations, the number of possible combination is pretty large, because we need to find out the solution of 10 times 9 times 8 and so on. So these values end up with the factorial of 10, and this is about 3.6 million. This large number of combinations we have to pass to cover to find the optimal solution. So let's start from the begin, and here is the city which is using the VLOOKUP function to find the order. Inside the VLOOKUP function, we have to place the F14. So let's place the order like that. One, it finds the Boston, and then we implement the same kind of sequence, and let it be like that. And for the distance, we need also we have to find the distance from the matrix which already calculated for us, and each distance is calculated with the previous formula 69 times square root of that. So let's find the index. Returns a value of the cell at the intersection. So the index will be the array of distances. This is the array of distances, and the intersection will be the row and the column. So between Boston and Chicago, it is 983 values. Between Seattle and this value. This will be from Seattle to Boston, this value. And let's find out the total distance traveled, which is just the sum. Total distance as the starting point is 18,775 miles. So let's use solver to find out the minimum distance possible to travel. And we go to data solver and set our objective as this value. And we're going to change cells, the order in which the person travels, and our single condition on our problem is just to not let the courier get back to the previous city unless he or her travels all the cities in the sequence. So that means each city in this column should be different one. And let's use the add order, and here's the option which is called different, all different. Replace over here. Yes, it should be evolutionary solver, and we make unconstrained variables non-negative and try to find the solution. So there might be different options. Yeah, hold on, we need to find the minimum value. Stop, because it tries to find the maximum value. Solver minimum value. Hold on. TSP solver minimum value. So, okay, and now it tries to find the solution which derives the minimum value over here. We need to wait a little bit. It goes through making thousands of problems. So what happened here? It gives us the result which is not great. Why it is not great? Because it tries to find the it tries to find the order which is non-integer. So it tries to find something like 1.1, and these values are not great. So what should we do? The reason for us to keep the order is to make in the solver the variables which are integer. So here they should be integers. And then inside our options, we'll make sure that we have the mutation rate set, and we have the maximum time result improvement set over here. So let's try to find, maybe it's possible to find the solution. And once again, it tries to find something which is pretty different. So let's start to find out why doesn't it working properly. Here in the solver, we need to explore the options. This is maybe this constraint is not what we need. Maybe we need to check. And now it finds, yeah, so we have to make be really careful with the options that we set. What I can see for now, it has found the route 8995 miles with the integer constraint removed. So the single option that was really bad here is this solving with integer constraints. So generally when you select those ignore integer constraints, it tries to find non-integer solution because it is more easier for the solver to find the non-integer solution. And integer optimality might be set to not just 0.05%. Generally, you can set it to like 1%. Change the precision and scaling and everything. Also, there might be different options like the derivatives which are forward or central. It might help. And inside the evolutionary solver, the uh, options were set to these particular values. So even with the tick which removed about the integers, we don't need to implement integer constraints over here. So all in all, this solution is really good. And the route is circular. That means that it doesn't matter from which point you start. Maybe you can start from LA, go to Phoenix, Dallas, and so on, and then return to San Francisco, and then return to LA. This is the option for traveling salesperson's problem. And these kind of problems are everywhere. Just what is the optimal sequence of events to cut holes in in the wall? What is the minimum distance? What is the best flight plan? What is the best way to minimize copy time? Something like that. Everything is everything which can be placed in the sequence of events. So this is the travel and salesperson problem. So TSPs are solved with this kind of solver, evolutionary solver. All right, so all in all, what we covered today. We covered today the GRG nonlinear solver, which is great when you are dealing with nonlinearities like square roots, or maybe there are different like squares or cubes or anything which is nonlinear. And there is an evolutionary solver which deals with the problems which are including non-smooth functions. What are these kind of functions? These are the means, minimum values, absolute values. These are the functions which require the problem to be solved with multiple points or traveling salesperson's problem. They all require evolutionary solver. Just what you need to take care of the options. The options are really important there, and you always have to value your solution which you obtained and make it reasonable and logically explainable. So here the order is okay, and the total distance is significantly less than the distance that we obtained initially. Next, what you need to use to check that your solution is workable, you have to change the initial start of the points. So maybe you have to set like 4, 11, 10, but maybe you need to 6 change those values a little bit, not just 1, 2, 3, 4, and so on. That was our initial start. Change it randomly somehow and check whether the solution can be found the same value, or maybe it will be better. Sometimes if the initial set of points is really important for you. So that's it. You will have the practice. The practice will involve checking the sequence of events, the TSP problem. This is problem number 2. And problem number 1 is using the different value of satisfaction and quality as in our first task to solve the assignment of workers to groups. Okay, thanks for watching. See you next week.